Hi everyone, my name is Ravi. In this session, we'll discussing this fantastic set which is in front of you. Okay, and this is will be part of a number-based LRDI. You can see this is a typical cat set in today's terms, right? This kind of sets are asked these days in cat. Okay, which involving a bit of hit and trial, on the spot thinking. Okay, so that kind of thinking we need to generate. Okay, so this kind of sets will help you to take through LRDI section in CAT. Okay, so very good set, right? I hope you first pause this video, attempt it for 10 minutes, and then you see this video. Okay, now let's discuss it. Let's discuss it now. See, in the table we have given below, the letters A, B, C, D, E, F, G represents digits chosen from 0 to 9 such that A into B into C is equal to B into G into E equal to D into E into F. So A into, it's like A into B into C is equal to B into G into E is equal to D into E into F. This is the funda here. This is the funda here, right? So you have to solve it like this, that all these numbers match. Okay. And then there are questions here. Which three digits are not represented by any of the 7 letters? Which three digits are not represented by any of the 7 letters? So see, this first question we can do it easily. From there on, right, we have to basically find out all these numbers. We have to basically find out all these numbers to solve for this set, right? To find out all these numbers to solve for this set, right? But first one is quite easy. We can do it. So see, obviously you can sense it since the digits available for you are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, these are the 9 digits available for you, right? So out of this, obviously one can't be 0, right? These A, B, C, G, D, E, F are the 7 letters, right? So there are 10 digits in front of you, obviously. So 3 are extra. The first question is which 3 are extra, right? That means which 3 digits are not represented by any of the 7 letters. So obviously you can say that any digit, right? A into B into C. So A into B into C is equal to B into G into E is equal to D into E into F. So obviously this A, okay, anyone cannot be 0, right? Suppose anyone is 0, right? Suppose A is 0, then whole becomes 0. Suppose what I'm saying is if A becomes 0, so if A is 0, in that case first terms become 0, but now second term and third term cannot be 0 because they all distinct. They are all distinct digits. They are all distinct digits, right? So now third term and fourth term cannot be 0. That's why 0 is not possible, right? So all those numbers, right, involving, so you can get an idea here. Okay, now what is the next number which cannot be any of the digits, right? The next number which any of the cannot be letters, right? What is the next number? So obviously because all these terms, right, you see here, a is occurring single time. Okay, now B is occurring double time. Okay, now E is occurring also double time here, right? And D and F are single time. D and F are single time, right? So from 0 to 9, all the digits which doesn't have any factor. Listen very carefully, right? All digits which doesn't have any factor. Digits like 5 and 7. That doesn't have any factor. Okay, 1 I can take because 1 multiplied with any number gives back 1 only, right? So it's okay. But 5 and 7, right? Suppose what I'm telling is that if let's say A is equal to 5. So if A equal to 5, this first number is a multiple of 5. If A equal to 5, then this first number is a multiple of 5, right? But since we have only one 5, so second group and third group cannot be multiple of 5. They cannot be multiple of 5k, or they cannot be a multiple of 5, right? So if any of this is 5, so it is not possible, right? So that means for any of this to be 5, it has to occur in all 3 terms. So say, right, even if you take like here, I told you, B is occurring twice. If you take B is equal to 5, in that case, first term is a multiple of 5, second term is a multiple of 5, but third term cannot be multiple of 5 because a maximum time a digit repeating here is only 2. And from 0 to 9, 5 occurs only once. So that means two terms can be a multiple of 5 and third term cannot be a multiple of 5. No way, right? So maximum, right? Since I can see here and B and E. B and E are repeating twice. Other all A, G, D and F all are single time, right? So that means no single digit. If A cannot be equal to 5, right? A cannot be equal to 5. So no single digit. So that means no single letter. Like single letter occurring are A, C, G, A, C, G, D and F. A, C, G, D and F all cannot be equal to 5. Right, so if B cannot be equal to 5, then all the letters occurring double times, B and E also cannot be equal to 5. Same is the funda for 7. Same is the funda for 7. Same is the funda for 7. Okay, same is the funda for 7. Right. What is the funda for 7? For 7, this again same thing, right? Because 0 to 9, 7 occurs only once. So if any single digit is a multiple of 7, then that 7 can occur only one time in this 3 term, right? See here, A into B into C is equal to B into G into E is equal to D into E into F. So if any single digit like a single letter, like in all 3 order single letters, double or only B and E. B is occurring twice and E is occurring twice. So if A is equal to 7, if any single letter is equal to 7, so this whole term is a multiple of 7. Now this term cannot be multiple of 7, this term cannot be multiple of 7 because there's only one 7 available, right? So that's why I told 5 and 7 doesn't have any factor. 5 and 7 doesn't have any factor. So 5 and 7 cannot occur in these places, right? That means what is 0? Already we saw 0, any one digit cannot be equal to 0, right? So already any one digit cannot be equal to 0, then 5, then 7. So what is the answer? Answer is C, 0, 5 and 7. Which 3 digits are not represented by any of the 7 letters? Answer is 0, 5 and 7. Correct? Now let's move to second question. Right? See, second question says, what does the letter G represents? Right? What does the letter G represent? Okay, so second question is, what does the letter G represents? Right? So basically now we'll find all the value of digits, right? Like A, B, C, G, D, E, F. We'll find all the digits and all the cases, and automatically you can answer all the questions, right? We're learning here. Okay, so we can solve all the digits now. A, B, C, G, D, E, F, right? So see, when we solve all the digits here, see, we have like this cases we know, right? This cases that A is equal to 8 or A is equal to 1. We know that A is equal to 8 or A is equal to 1. Okay, so see here, what will happen when A is equal to 8? What will happen, right? So I'm taking first case here, case 1, when A is equal to 8. Understand this now very carefully, right? See, all the digits I have now, once we factorize all the digits, right? All the digits I have now is, what are those digits basically? So all the digits I have now is 0 to 9. Okay, 0 to 9. So options I had initially were 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Out of that 0, 5 and 7 are gone. Since A is equal to 8 I am taking, so A is equal to 8 also gone. So what I am left with is 1, 2, 3, 4 and 9. And since it is case of multiplication, so obviously we have to balance the factors. Balance the factors means, suppose I take A is equal to 8, right? If I take A is equal to 8, the first term contains A into B into C. So see, if A is equal to 8 here, if A is equal to 8, so now total, what is 8 here? So 8 is made of, what is 8? 8 is made of twice, 8 is made up of twice, 3 2s here. So obviously so we'll see how many 2s I have, right? So okay, 8 has 3 2s, 8 has 3 2s, then 6 has 1 2, then 4 has 2, 2, and then 1, 2 is here. Total I have 1 plus 2, 4 plus 1, 5. Total I have 8 twos. 5 plus 3, 8 twos, right? Total I have 8 twos available. Total I have 8 twos available. So out of 8 twos, since 3 twos I am using the first term. If A is equal to 8, so 3 twos I am using in the first term. Here's the first term. 3 twos I am using in the first term, right? So obviously, I should not use B and C. I should not take any value of 2. If A is equal to 8, if A is equal to 8, then understand this point, then B and C cannot be equal to 2, 4 and 6. B and C cannot be equal to 2, 4 and 6, right? Because if, understand this now, if B is equal to 2, what will happen? If B is equal to 2, then this term becomes 8 into 2, 16, right? This term becomes 8 into 2, 16. To balance it, here what you need is, since it has 8 into 2, 16, so now first term has got 4 twos, okay? I'm writing here. Now first term has got 4 twos. So 8 A into B into C is now 8 into 16. What I'm telling that if if A is equal to 8, B and C cannot be equal to 2, 4, 6, because if A is equal to 8, and suppose I'm negating this, okay, I'm supposing that, okay, B equal to 2, then first term has got 16, that is 4 twos, okay. So if the first term I got total 4 twos, 3 twos in 8 and 1 2 in 2, total 4 twos. So second term also needs 4 twos. For second term 4 twos, okay, B has assumed to be 2, so B is 2, 2. I need further 3 twos, okay. So 1 2 is in 4 and 1 2 is in 6. So okay, so now second term also has 4 twos. Right? But third term cannot have 4 twos because D into E into F. Now E is only 6, so E is only 1, 2. D and F cannot be any multiple of 2 because there are no 2 left. I've used all the multiple of 2s here. 2, 4, 6, 8. 2, 4, 6, 8 or are already used, right? So number of 2s cannot be balanced, right? Number of 2s cannot be balanced. That's why B cannot be equal to 2. That's why I've written here that in this full column, if A is equal to 8, that is the first case. So if A is equal to 8, then B and C cannot be equal to 2, 4, 6. If A is equal to 8, B and C cannot be equal to 2, 4, 6, right? So okay, so A is equal to 8 I am putting. So what is the value of B then? So B, if B and C cannot be equal to 2, 4, 6, what are values left for them? 3, 9 and 1. The values left for them are 3, 9 and 1. Now again interesting case, right? Once you get for 3, 9 and 1, this 9 contains 3 square, that is 2 3s, and this 3 contains 1 3. Total we have 3 3s, right? 9 contains 1 3 and 9 contains 2 3s, 3 contains 1 3 and 6 contains 1 3. Total I have 3 3s, right? So I can write here, this thing very important. Total I have available 2 raised to, total I have, how many 2s I have available? 3 plus 1, 4. Total I have 7 2s available. How many 3s are available? So 3s, here is 2 3s in 9, in 6 1 3, in 3 1 3. Total 3 raised to 4 are available. So I have 7 2s and I have 4 3s available, right? I hope it is clear, no? Any mistake? No, it's fine. Yeah. So I have 7 2s and I have the 4 3s are there, right? So once A is equal to 8, that means there already 3 2s are here, right? So these values has to balance with all the 3s. All the 2s and 3s it has to balance, right? So now if A is equal to 8, understand this. Now if A equal to 8, B and C cannot be equal to 2, 4, 6. So I can put B equal to what I can do? I can put B equal to 3. Okay, let's put here. I can put B is equal to 3. So if A is equal to 8, I can put B is equal to 3. Okay. So if A is equal to 8, I can put B equal to 3 and I can put C is equal to, now I can put C is equal to what? I have option left with only 1 and 9. Since it can't be 2, 4, 6, so C is 1 or 9. Understand this again point very, very carefully. Now C cannot be 1. C cannot be 9. Why C cannot be 9? Why C cannot be 9? C cannot be 9 because if C is 9 here, for two reasons, right? If C is 9 here, then we have only total 4 threes available, right? So if C is 9 here, that means 2 threes I'm using in first row only. 2 threes I'm using in first row only. So for second and third, right, if the first term, what I'm telling is, if the first term, okay, if the first term contains 2 threes, if the first term contains 2 threes, then second term should also contains 2 threes, and third term also should contain 2 threes, right, to balance it. But since I am putting 2 threes in first term only, at that 2 of C, that 2 of C, so C cannot, that 2 of C, so now for second and third term I am left with, so since I am using 3 square here only for C, so in that case I am left with only 1 3, 1 3 here and 1 3 here. That means threes I cannot balance in all the three terms. That means C cannot be 9. C cannot be 9. Right? So if C cannot be 9, for sure C has to be 1. For sure C has to be 1. C cannot be 9, for sure C has to be 1. C cannot be 9, for sure C has to be 1. Right? C has to be 1. So now when C is 1, then B is 3 or 9. Correct? When C is 1, then B is, because B and C cannot be 2, 4, 6. So when C is 1, B has to be either 3 or 9. Now see here. If B is 9, what will happen? If B is 9 or B is 3, I can take two cases here. So what will happen if B is 3? What will happen if B is 3? So if B is 3, again 3, number of 3s has to be balanced, right? Number of 3s has to be balanced. So for balancing 3s, here in second term also 1 3 has to be here, and in third term also 1 3 has to be here, right? At least 1 3 has to be. Understand this? In first term also 1 3 will be there, in second term also 1 3 will be there, right? But there are 4 threes we have. See, we have 4 threes. We have 4 threes. Once we have 4 threes, so in the first term, if I am putting, I'm writing here only, in the first term, right? We got all this point till now. Okay, listen to every sentence very carefully. Since we have all threes, sorry, we are getting, since I am saying B is equal to 3 or 9, B equal to 3 or 9, right? So if I put B equal to 3 here, that means B equal to 3 and A and C are already not 3. Then first term contains 3 raised to 1. But one digit is also 9, dear. One digit is also 9, dear. So that means somewhere on the line, somewhere it will contain 1 9. Some or the other places it will contain 9, right? So again 3's cannot be balanced, because first term contains only 1 3 and 9 has to be a digit. 9 has to be a digit among A, B, C, D, E, F or G, right? 9 has to be there. So if any one term contains 9, that means it contains 2 3's. It contains 2 3's, whereas first term contains only 1 3. That means B cannot be 3. Therefore, B has to be 9. So we got this here. So very, very important data we got here, that B is equal to 9. See the logic behind solving, right? Why I am putting so much effort is to explain the logic, right? Once you have tried this set for 10 minutes and you listen to all the logics, right, that will really open up your mind. Okay, and we are doing some fantastic sets in LRDI, and we'll continue this saga, right? We'll continue the saga of doing fantastic sets in LRDI. You just have to be open-minded, right? I'm bringing all the tough materials for you, all the good materials for you. I'm creating all the good sets from you. Some previous year CAT, some previous year ZAT, some my created sets. Okay, everything, every kind of logic I'm bringing to you to have an open mind, right? Thinking level should be increased. A good IQ level is required, right? So that's why. So A is equal to 8, B equal to 9, C equal to 1. We got it, right? So very important data we got. A is equal to 8, B equal to 9, C equal to 1. That means, look here. That means A into B into C is equal to 8 into 9 into 1. That is 72. Now this is equal to B into G into E. This should be equal to B into G into E. This should be equal to D into E into F. Okay, now what is B here? What is B here? B already is 9. So B already is 9. So this 9 and 9 is balanced, right? Now to understand this point now, to balance this 9 and 9, to balance this 9 and 9, because first term also contains 9, second term also contains 9, right? Now, since we have total 4 threes here, so 3 square I am using. 3 square I am using, right? So our main task is to now balance it, right? So I know that B is 9. I know that B is 9. Now, obviously, now G and E, right? So since I need to balance here G and E, because I know that 9 into this term also needs to be 72. Second term also needs to be 72 with 9 and with number of threes and number of twos perfectly balanced, right? So how to keep here? So how you can see, put some hit and trial. See some hit and trial here. How you can put G and E as 72. G and E as how you can get 72 here, right? So you can get 72. Obviously, first be sure that here in G and E, here in G and E, you can't put any 3. You can't put any 3, right? Why you can't put any 3? Because here it is 3 square, here it is 3 square, right? First term contains 3 square. Second term contains 3 square, right? So third term also should contain 3 square to balance it, right? So one way is to see, okay, I can put E equal to 3 so that E3 comes here and E3 comes here. But 9 into 3 is 27. 27 into some digit cannot be 72. Cannot be 72. That means E cannot be equal to 3. That means E cannot be equal to 3. Right? For sure, E cannot be equal to 3. Okay. Okay. Now, second thing, if E cannot be equal to 3, then what is the other possibility here? So I cannot, so G also cannot be equal to, obviously G cannot also be equal to 3 for the same reason. If G is 3, then 9 into 3 is 27 and 27 into something I cannot get as 72, right? As an integer, I can't get 72. So obviously G also cannot be 3. So E and G both cannot be 3. So what option I'm left with here? Only option I'm left with is to be 2 and 4. To be 2 and 4, right? 2 and 4. So I can put G as 2 or E as 4 or E as 2 and G as 4, right? I can put anything. So let's check here, right? Let's check here. So what I'm saying is I can put anything. I can put G and E as 2, 4 or 2, 4. 2, 4 or 2, 4 I can put, right? Anything can be 2 or anything can be 4. That is not known now. Okay, let's say, let's for example, so I am putting, for the time being, I'm putting G equal to 4 here. So if I put G is equal to 4 here, then E will become 2 and this number is 72. This is equal to what? This is equal to D into E into F. So E is already 2. So E is already 2. So obviously what I'm left with only 3 and 6. I'm left with only 3 and 6, right? I'm left with only 3 and 6. So once I put 3 and 6 here, 3 into 6 is 18, 18 to the 36. It has to be 72. It is not satisfying. That means again, G cannot be equal to 4. So because if G is equal to 4, then E is equal to 2, right? So if G is 4, E is 2, then if you put E2 here, so I'm left with only 3 and 6. Out of these options, all are finished. Only 3 and 6 are left. So all it should give me, this is equality sign. They should also give me 72. 3 into 6, 18, 18 to the 36, not giving me 72. So also E cannot be 2, right? So E cannot be 2, so G cannot be 4. So if we are confused between E and G, 2 and 4, so now if G cannot be 4, so obviously G has to be 2. So obviously G has to be 2, right? So now G is 2 for sure. So G is 2 for sure, right? G is 2 for sure. Therefore, E is now 4. If G is 2, then E is 4. If G is 2, then E is 4. Right? I hope you're getting every point, right? If G is 2, E is 4. If G is 2, E is 4. So now E is 4. So now for D and E, we are only left with only two options. 3 and 6. Either 3 and 6 here or 6 and 3 here. For sure, right? I can make either 3, 6 here or 6, 3 here. We can have two cases, right? We can have two cases, right? So for D3 is for D3 F6 or D6 and F3. Okay. So what does my case look like now? So my case 1 looks like A is equal to 8. So D is equal to 3 or 6 or F is equal to 6 or 3. This is my This is my case 1. This is my case 1. Correct? Right? I hope it is clear. Okay, this funda. 4 3s and 2 7s are here. Okay, so 4 3s and 2 7s are here, right? So let me make these cases here now. So I'll just make these cases quickly. Okay, so my case 1 was if a equal to 8. Similarly, you should form case 2. You should form case 2 with a equal to 1. We already discussed that in these two places, right? If a equal to 1, right? So now a equal to 8, now second case is a equal to 1. Okay, this case I'm leaving on you, right? You have to solve it. If you understood all the explanation, right, so you should get the answer. Okay, so first case, what I'm saying is, this is the case 1. This is case 1. Okay, in case 2, how you should get is, let me make a 3x3 block here. Okay, so what you should get is, in second case, if you put a is equal to 1, in second case, if you put a equal to 1, by all the hit and trials, you will get b as 9 and c as 8. Right? For same reason, you can understand it. You can understand it now. Why 8 is in the first row. Okay. Then g will be 2 here. G will be 2 here. Then this is 4. Then this is 4. And same way, this term can be 3 or 6 or 6 or 3. This is case 2. So this is case 1. Right? This is case 1. And this is case 2. This is case 1 and this is case 2. Right? So I hope you got it. Right? Case 1 and case 2. Okay. So let me make it now. I can make this case 1 here. I can make this table here also. So let me make it case 1. Case 1 was if a is equal to 8. So what we got is, quickly I'll make it so that we can solve other questions very easily. So a was equal to 8, b got to be 9, c got to be 1, g got to be 2, d is 3 or 6 or 6 or 3. Okay, I hope it is clear. This is case 1, this is case 2, right? Case 2, please do yourself. Please do it, right? I'm pleading you to do, right? All this concept apply for when a equal to 1. Put all those hidden trial. If you get this box, you'll feel very confident, right? You'll feel very happy, right? And all my efforts will be fruitful, right? Now, we'll see. So what is the answer? What does the letter G represents? So G represents what? G represents 2. 2 is the answer for second question, right? Now you can do third and fourth easily now. Third question now. See third question. Okay. See third question now. Third question is, if B is equal to 4, then A is equal to what? So in this question, it is giving that if B is equal to 4, then A is equal to what? Right. Okay. So let's move to question 3 now. Let's move to question 3 here. So question 3 is, if D is equal to 3, then F is equal to what? Right. So we know this now. In both the cases you can see here, that D is either 3 or 6 and F is either 6 or 3. That means if D is 3, F has to be 6. If D is 3, F has to be 6. So answer for this question will be 6. Answer for this question will be 6. 6 is the answer. If D is 3, F is 6. Okay. Fourth one. Fourth question is, fourth question here. Fourth question is, what is the value of A into B into C? Fourth question is, what is the value of A into B into C? So what is the value of A into B into C here? So A into B into C in both the cases is 1 into 9 into 8. So 1 into 9 into 8 or 8 into 9 into 1. What is the answer? Answer is 72. 72 is the answer for this fourth question. A fantastic set of numbers based LRDI, typical set asked in CAT these days. Okay. So I hope it is clear. Okay. All is fine. Thank you. So we'll continue LRDI in the next videos. Okay. Do watch it. Practice it. LRDI. All the best.